Hello everyone, my name is Pisek, or you can call me Benj as well. I'm from Keston. Keston promises to bring you actionable insights about AI and generative AI so that you can empower yourself, your team, your work, and your life. Today we are in episode 22, and what we are going to talk about? Today we are going to talk about AI agents made with LangGraph that has Python interpreter as a tool, and you can access a database. Aside from that, we are going to integrate it into a beloved Open WebUI so that you can have a chat interface, nice chat interface with your AI agent. Before we actually start it, don't forget to subscribe to our channel. We are on YouTube, LinkedIn, Facebook, X, and Substack, or even GitHub as well. Next thing is, I want to personally invite you to join our community. We are planning to release courses and establish a community to learn about AI agents. We'll make it a simplified version for you. So don't forget to subscribe to this activity as well. And then you'll be the first to know if we have updates or even discounts to our courses. All right, let's actually get started. Again, today we are going to make AI agents. We are going to make it out of LangGraph, and we are going to equip it with Python Executor. And with the Python Executor, you can do many things. And one of the things that we'll do today is to access a database. We implemented with Postgres today. So you are going to see it live in action. And then once we have the AI agent, I'll show you how to integrate it to a very popular UI tool, the Open WebUI. So let's actually get started. Let's start with the AI agent itself. We are going to make an AI agent with LangGraph. I choose LangGraph because I want control. I want to dig into the detail and implement the flow of my agent at will. There are many other multi-agent frameworks out there. LangGraph is one of them. You may want to choose other repos such as Crew AI, Small Agents, and AutoGen. And I believe those frameworks can also be integrated with the Open WebUI. And I think I will do a video on those tools or frameworks and how to integrate it with Open WebUI later. But today we are looking at LangGraph. All right. The way to do multi-step agent with LangGraph is actually quite simple. This is just a very tiny graph that actually implement multi-step agent already. In this graph that you will make with the LangGraph, you will have the LLM node, and it's going to give you reasoning power. And it has autonomy to choose whether it's going to need to use tools that you equip it with in order to solve the to solve the questions posed by a user, or it can just provide the answer already and end. So with this, it's actually a multi-step agent already. And today we are going to equip it with a Python executor. And with Python executor, the agent can write Python code that will connect to the Postgres database, as I'll show you today. And if you watch my earlier videos, these are the main components, at least the necessary components to enable multi-step agents. Memory, the React framework, forcing the LLM to reason and act and then respond. After that, you equip it with a tool and you have a loop, right? You want to give autonomy to the LLM to keep doing things before it can form a final answer. But you don't want it to get stuck in the loop, and therefore you have a termination criteria. Everything here is implemented with LangGraph so that you have a multi-step agent for you. Now, let's actually go to the coding section. This is going to be a little bit more technical. You can skim through to the next section that I will talk about Open WebUI and Pipelines. But now, before we do that, we are going to demo how to create LangGraph agents in the coding walkthrough. All right, here it is. This is my repo that I prepare my LangGraph agent. So I did some architecture here. My agents will be kept in this folder. Other secrets and credential will be kept in the config. Tools, I will show you the local Python executor tool as well. I actually don't need the Postgres tool because the Python executor will do the heavy lifting in writing code and connect to the Postgres itself. So let's actually focus on how I define my data analyst agent with LangGraph. These are basic import stuff. You will import everything that you need. And I'll also import a Python executor from this file here. So let's jump into this file before we continue our agent. I need to thank the Hugging Face team, especially the small agent repo. I take this file from that repo. It's very nice and clean way to create a Python executor. You can define base built-in modules that the tool can access. You have many other helper functions, but what I like about here is it has blacklist some modules that local Python executor shouldn't do, so that you don't corrupt your environment. So if you take a look into small agents, it has a nice description of how to use this and what features it has. But basically, this is going to provide your agent with a Python executor on your local machine, and you have ability to say to authorize some imports, right? You can come to the end of the module here, and you can see that this is what we are going to use, the end goal class, but I'm actually using this one. So this encapsulate whatever it has in this file. It will trigger, it will instantiate a local Python executor here, provided you can provide it with an authorized import, and then it will execute the code. So all in all, this is going to be a function that I will give it to my agent to have access to local Python executor. And the way we are doing it here is we are going to import it to our agent module here. For this one is to actually load from .env file anything related to the environment variables, for example, OpenAI API keys that I have saved in the .env file somewhere here. Anyway, so this is just preparing my code for my agent. The default model name is GPT-4o Mini for now. This is my system prompts as a default. The agent will name Casey. She is an advanced data analyst assistant equipped with data analyst visualization and problem solving skills, and so on and so on. And I kind of like apply a React framework in the prompt here. It will force the AI to think and then determine what kind of actions or tool use it needs to conduct. And when the tool returns something to the AI, it becomes observation, and it will try to answer based on the observations, or it will choose to trigger multiple calls. And this is just a prompt. Now, I also provided with a default Postgres prompt to tell the AI, okay, if you are going to use a PostgreSQL database via Python executor, how to do it. For example, I give it an example that, okay, you might need to load the .env file in order to access the username and password to the Postgres server. The Postgres host is here, the port is there, and maybe you need to identify that, okay, I want the database called Postgres in order to list out what databases in there. But basically, this is a few short prompting. I give the model in the prompt, via prompt, some examples of how to do some task. This task is related to listing what tables are available in a particular database, right? These are two prompts. Vowels, we'll cover that later on, but what I want you to focus here is majorly about how to define LangGraph agent. I'm not going to do a detailed introduction because I am going to make more video on LangGraph agents specifically, or maybe a course. So don't forget to subscribe, and then you will get to learn a best practice course about how to create agents and stuff. But pretty much in LangGraph, if you want to have or enable memory for your agent, you need to uh, define a state. And this is my state. It's very simple state. It only has messages, and it's going to be a list of messages that matters here. This line is going to define a Python tool for my agent. Recall that I'm going to use this function imported from this file over here. Now, this is going to prepare a tool for my agents. This function is going to help me create an client to talk to ChatGPT, OpenAI server. So this is going to act as my LLM, large language model. The default is going to be, a client with this API key, and the model is going to be GPT-4 or Mini as a default. But I can pass many or other models name into it, like O3 Mini, for example. Now, those are just variables, definitions. The actual magic of creating a graph is contained in this function, create agent builder. Well, it takes LLM, tools, empty for now, and a prompt, system prompt. And you can see here that I combine the two prompts that I showed you earlier, the system prompt and the prompt to instruct the model how to use Postgres tools. Okay, well, moving on. This is just tools again. And this step, we are binding tools to the LLM. Now, the LLM is equipped with the tools. In this step, we are defining the node of the LLM. And the node is going to be named LLM node. The tools node is going to be called tool. And that's it. That's enough definition. Now we are ready to make the graph. The graph builder will be added nodes. The first node is the LLM node itself, and the second node is the tool node. And then we have a conditional edge that signal to the LLM node that you can choose to use the tool. But when the tool is used, it needs to return to the node. So this is an edge. This is conditional edge. And that's it. Once you have this builder, you compile it, then you get a graph that is this one. So basically, what you saw in the code, when you run compile it, you get a node like this. You get a graph like this. It's actually a multi-step agent already. All right, so let's actually give you a first demo. So this demo is going to be a very basic one. So let me just clear it and restart my kernel. Hopefully there will be no bugs. Otherwise, I am embarrassing myself to the whole world here. But anyway, let's go. So I import this. Now I have my LLM, and to show you my LLM is, I can run, LLM, and it's going to be a chat OpenAI API. We have a client ready, and our model is a GPT-4o Mini here. Now again, with the create agent builder, I provided with the LLM that I want. I have a graph builder but I need to build it. And the way to build it is to use a compile method. Inside the compile method, you put memory in it so that now the agent can keep messages with the LangChain or LangGraph backend. So I am going to define my agent. And the way LangGraph works with memory is you provide a config. Oh, this is just how the way it works. It handles chat sessions with thread. So pretty much use the same thread if you want to continue the same chat history before, or you can switch to other thread by providing it with a different thread ID. But let's just keep thread ID as 1 for now. Visualizing this graph, the graph now is here. So it's in the visualization. It ends with 700. So this one. So yeah, it's the graph that I showed you before. The reasoning node is here, and we are going to equip it with tools. It can choose to use a tool, or it can choose to give answer and end already. But when it's in the tool, when the state is in the tool node, it needs to return. It needs to return, no choice. That's why it is a solid line here. Back to the LLM node, who will decide whether it needs to trigger to again or end and respond. All right. Okay. Just to kickstart with something here. So, okay. I am going to run this, and the question is a side of 60. Now, just to remind you that this agent is made from the Data Analyst Agent, which already has access to the Python executor tool. So if the question is quite tough, well, side of 60, if you can remember, if you pay attention in school, it's square root 3/2. It's a simple or very repeated answers on the internet. So maybe I just need to test it out with like very crazy, difficult to remember answer. I don't know, like if this is going to be, who can remember this? I don't know. But so this is the way we want to test your function, right? Whether your agent, whether it can actually trigger the right tool calling or not. Now I have the responses back. Take a look into the message key here, and you can see that this is the information that you sent to OpenAI and you ask the model to do. So the second message is this guy. AI message content is empty, but you have other information that tells you that the AI thinks it needs to call a tool, and therefore the code that it wants to call is this one, import math sign of this one. And eventually the tool provides back the answer of this much. Sign of that much is this much. And with the tool response, the AI would then say, sign of 20,000-ish is this. So you send the message to your AI agent. It decided to use a Python executor. It wrote a code, a Python code, and give it to the Python executor to execute, return a value, and then the AI grab that value and transform it into a final answer, right? I don't like to debug this, so I made another tool for myself to show it in Gradio. So I'm going to run this. It's going to import a class that I can use to run the code. And I can show you again here, but maybe with a different prompt. So let me just zoom out a little bit so that we can see the whole thing. All right, I'm going to ask, what is a log 10 of 1, 2, 3, 4? Hopefully it knows that it needs to use a Python executor again. Now, with the code that I wrote for the Gradio UI, I can toggle and hide information inside a tool call. This is neat. So it decided to use Python executor. And I want you to focus here. This is the way we define the local Python executor. You see this authorized import. So the AI knows what argument it needs to provide it for the authorized import to call this tool. And, it write the Python code to do that for me, man log 10 of 1, 2, 3, 4, and get the answer back. This is as simple as it is. You have a AI large language model. In this case, it just does GPT-4 or mini, very, very affordable. You equip it with a Python executor, and it writes codes, trigger tools, get the answer. That's simple. The second example is going to extend what we did before by involving a database. So when we talk about database, let me show you the database that I have implemented. I have Postgres installed in my local machine. This is like a PG admin, and it allows me to serve a Postgres server locally, so that I can give you guys a demo. In the database in my server, there are two of them. The default Postgres database and the one that I made myself is a coffee shop emulator. Inside the coffee shop, I have three tables that matters. The transaction data, the store master, it will list, it will have like what stores I have, and the product master. So let me show you the product master. So I'm going to view all the rows here. My apologies, it's a little bit small, but you can see here in the bottom that I have product ID, product name, category, descriptions of the product, price, size, availability status, created at, updated at, well, a minimal version of the product master for your business, well, in this case, a coffee shop. And then I want to show you the store master. The store master, as the name suggested, contain information about stores. And in this minimal, I can, enlarge. Well, in this version, I have the store ID, store name, short address, like Union Park in New York. My branches are focused or located in New York City, the city that I like. Anyway, so this is the minimal version of the store master. And to show you the last one, the main one is the transaction data. So I am going to, show all rows. I think I have like about 3 million rows here in this transaction database. It will have a transaction ID. Each transaction ID is associated to one particular bill a customer buy. In the bill, you can have many products, right? And it's going to be encapsulated here. The way I do this is bill will have product IDs. It will have associated product price, the quantity, subtotal, and the total of the whole bill. This is the minimum version of the transaction data that I have. So what I want to show you here is how, with the minimal, very tiny agent like this one in LangGraph, where you equip it with the Python tool executor, you can have a data analyst working for you directly. All right, so first of all, let me execute this. This is just going to import. There's nothing much. Now, I want to show you explicitly that the system prompt now is a combination of the system prompt and the Postgres prompt that I divided and showed to you earlier. And I want to take this liberty to change it to GPT-4 or mini because somehow I found that the O3 mini performed worse in writing codes. I think it can be because O3, the old version, is supposed to be for advanced reasoning, and somehow it's just an overkill for the application that we are going to show. Anyway, and also for cost-effective purposes, GPT-4o Mini is quite cheap too. All right. The way I constructed the Create Agent Builder allows for you to customize your system prompts. Even though the default is already this one, I'm just showing you the capability that it can do here. So I'm going to run this Agent Builder. All right, I've got the Agent Builder. Now it's time to actually build the agent. And the app is launched for the Gradio. So let's go. I'm actually going to copy this one, put it here. All right, this is the agent that we want. So let me try ask, what databases do I have in my Postgres server? Well, hopefully it's not going to embarrass me, but now it should be going through, well, it has a system prompt. The system prompt has an example of how to do this question. It should now go to that knowledge, provided knowledge via prompt, write code up, and try to solve this particular request. And now I'm seeing this and a little bit nervous. It's taking longer than I think it should, like 30 seconds already. Now I think it's doing so many rounds of React framework, maybe because GPT-4o Mini is making mistakes and therefore it will need to redo many times. And now that I'm showing you, I think I'm afraid that I need to run this again. Actually, let me actually check whether it has an error or not. Nothing shows here, so oh, okay. Well, it didn't. Uh, it didn't fail altogether, but there are so many tool calling. I think it made a lot of mistakes. Maybe like write a bad Python code and run into a problem. And eventually it seems you have to go on going shoes. It didn't do it well. So, well, that's too bad. Let me just ask it to try again. Unfortunately, well, this is probably or could be the limitation of the GPT-4o Mini, that it tends to make mistakes because it's not a bright and smartest model out there. But let's give it another chance, and if still we see the problem, I am going to change it to O3 Mini, or maybe yet a yeah, it's failed. So let me just go back and terminate this. Restart. Okay, I'm terminating that Gradio session, and I'm just going to go with the big guy here, GPT-4o. Restart again to give us some assurance here, and then I'm going to run through the whole list, and then we just refresh it here. Okay, what databases do I have access to in my Postgres server? A GPT-4o is much larger than the GPT-4o Mini, and I suspect it to run slower, but it should be more accurate. And here it is. This is quite bang on. Um, it has come up with a code that eventually give it the answer that, okay, the available databases in my Postgres SQL server is Postgres and Coffee Shop, which is correct. Well, the lesson learned here is for data analyst task, maybe opt out for the GPT-4o because you need a processing or brain power. And then I can ask again, what tables do I have in coffee shop? Hopefully it will write the correct Python code. And we are going to examine the Python code a little bit deeper this time to see how it does things. Here it is. This is the code that it has the GPT-4o thought that it needs to use. This one is going to load credentials from the .env file. This is import SQL alchemy. I specified it in the prompt that use SQL alchemy to access Postgres. And also, this is the .env location of the .env file that it thinks it needs to access. And then this one is it's going to get user name from the environment variables, get the password, and eventually create a client engine talking to the Postgres and get a table from using inspector get table name. This is bang on from the few shot examples that I gave it in the prompt. There's nothing fancy here. Now, the task that I will give it now is beyond the prompt. It's going to improvise on its own. I want it to give list out columns in product masters. Now, this task is not included in the few shot examples in the prompting. So the LLM GPT-4o in this case has to come up with a solution on its own knowledge, and hopefully it will do the right thing. All right, the answer is product ID, product name, category, description, price, size, availability status, create at, update at, and well, let's actually check product master, and we are going to list out the columns. Here we go. We have pretty much the right one, right? So it's doing the right thing. It's doing it correctly. You can now ask whether it can aggregate. Well, let me ask it to what are date range? What is the date range in transaction data? I created transaction data as a mockup data, and it ranges from the 1st of January 2024 to the last day of 2024. If it's if the GPT-4 can find the right answer, the right code, it will get to the right answer, and hopefully it will be done in a few seconds. And the answer is well, why is it this long now? To find the date range in the description in the transaction data table, I will query, and it's going to do that. Wow, this is bad. Wow. So I again I'm not going to provide some more hints. It should be able to do it on its own. And a few times that I did it on preparing this code, it was going to do it. It was able to do it. So this is the problem. You might run into a consistency issues if you write code or make some AI agents in the way that I just showed you. If you wanted to do a production level, provide it to your clients, rigorous testing, and maybe a little bit or much more control in how the agent will behave. This is not going to be acceptable, right, if you sell it to other customers. But for demonstration purposes, it shows the potential that you can now have a AI agent equipped with Python executor, and then it can act as a data um, analyst for you. Okay, it's getting pretty long. Now we ran into an error, and I think this is the recursion limit. It has reached a recursion limit, which is the default is 25. So yeah, I think we are kind of like bad luck today. We can try another run, but I'm going to skip another run for now because we will have another chance to do this task again when we integrate it with Open WebUI. So I am going to leave this as is for now. And one of the things that I can say is that you can now you may think of a way to increase or catch the recursion limit or increase it to something like 50 when it fails. This is like a retry mechanism that you might need to think of implementing. Okay, even though it's not successful run, it provided you with some example of what's possibility and how easy it is to construct a multi-step agent like this. In the next topic, we are going to touch lightly about Open WebUI and pipelines because we are going to integrate AI agents that we make to the pipelines. What is Open WebUI? Just to give a basic background information for those who haven't run into Open WebUI before. Open WebUI is an open source tool allowing you to have a chat interface at least, but it has more capabilities, like it can do retrieval augmented generation. You can upload files and it will act as a knowledge base for you. You can chat with those knowledge bases, and you can integrate with Ollama serving models locally. You can choose to download a DeepSeek distilled versions on your machine. Can be your laptop or your private cloud virtual machines. Yeah, you can integrate Open WebUI with tools like Ollama, also open source. But again, it serves as a very entry level small team or personal users to have, chat interface, chat history logs, or even some kind of like user or roles management like that. But if you want to extend it to more advanced capabilities, the team that made Open WebUI provided you with pipelines. Pipelines is an extension of Open WebUI. It brings modular, customizable workflows that can be integrated as a model options here to the Open WebUI. But you need to write codes if the pipeline is more advanced. And for today's purposes, I think making your AI agent is an advanced version of using a pipeline. And that's why we're having a discussion today. Well, I have a lot of people asked me, well, because they couldn't configure the pipeline to integrate with Open WebUI successfully. So I wanted to put this slide out there so that fewer people will run into a problem. The way I do it is Open WebUI. I'm just going to use a quick version, the Docker image. Download the Docker image and run it as a Docker. It's easy. But for pipelines, because you are writing codes, you are going to run into bugs and errors. I tried the Docker version of the pipeline, and I think it's very hard to debug. So I choose to clone a repo, customize that repo for myself. But again, Once you have your pipeline running properly, whether it's going to be via Docker or Git clone and run it with the Python, you need to establish a connection properly. Don't forget to read this section. Well, it's actually provided on Open WebUI's website, but don't forget to do this carefully. Especially most people who run Open WebUI as a Docker forget to set this because they just read this and just use that. So it's not going to work. You need to change this to that. So let me be clear. If you follow my approach, which is using Docker image for Open WebUI and run pipelines like this, you need to do this. So let me just show it just to give it to rest. But first of all, let me oh let me start my Docker image here. All right, now I can access to the server from there. Okay, local 3000 8000. Oops. Okay, come on. Local host 3000. This is my Open Web UI, right? This is a lot of messages that ran into errors when I debugged my pipeline. So now I have my Open Web UI running in a Docker. Let me run a pipeline. We are going to revisit this in detail later, but let me show you that if I run the pipeline successfully, how I need to configure the connection with Open WebUI. So let me go into the conda environments that I need. And this is a way to run the pipelines. When it's successful, it's going to look like this. So now I have Pipelines API running. The next step is to connect Open WebUI interface with the pipeline. And the way to do this is to come to the admin setting, come to connection. For those who don't have this yet, you are going to click that and you put in this. What you put in to this part is this guy, host.docker.internal, and make sure that you notice the API key as well. And that's what you are going to put it there. And when you configure everything correctly, you click save, and this is what it is. You are going to have this one. Yeah, this is the password that I showed you. So pretty much this is it. For those who don't have this line, click add button and make sure that it looks like this. Put the host Docker internal colon 9099 there and put the API key there. Well, this is default API key that comes with the way you run it as simply as I showed you, but you have options to configure this yourself too. Well, just that's another topic that you can dive into in detail later. I'm not going to do it now. Now it's ready. You have your connection. To check whether your connection is successful, first, this page will not show any error sign. If you click save, it should be green or green. But the second good sign here is when you come to pipelines over here, you have whatever pipeline that you put there. All right. So this is the way to make a proper connection between Open WebUI and the pipelines. Okay, that's it. I actually showed you to run the pipeline. I clone it. Actually, one more thing that one more thing that I want to show here is this is the repo that I directly cloned from Open WebUI GitHub repo, but I actually made some changes. The first thing is I no longer use requirements.txt. I'm using poetry. Well, for me, I think it's better at handling packages dependencies. So I'm going to use poetry for now. The way I use it here is actually do I have it? Sorry guys, I'm jumping here and there. Oh well, I don't have it here. Well, too bad. All right, so let me recap everything again. So I'm using poetry instead. So I'm going to create a conda environment, and I'm going to use poetry to install all the dependencies that I want. And every time I run the pipeline, I will do what I show you. So I need to activate the conda that I want, and then I will run start.sh as is. That's, oops. Sorry guys, what is happening? I think I minimized it. Did I? Do, do, mm. Uh, where did it go? Here we go. Sorry guys. The second thing that I changed is the dot start itself. Because I told you I don't do requirement dot text anymore. I skip this. I don't do any installs here. So I commented it out. The third thing that I did, I changed the main file. Boop, 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 boop. Here we go. When you introduce a new pipelines, you need to put your code here in this folder. And for whatever reason, when you run start.sh and there is an error, this chunk of code is going to move your file into a failed folder that it will create. This is so annoying. I just want ability to fix it and run it again quickly, and therefore I commented this chunk of the code out so that my file remains where it is so I can debug easily instead of having it automatically put into a failed folder and then I had to retreat it back. So this is what I did. That's it. So clone, customize, run it, and then you can now integrate pipelines with Open WebUI. All right, the last part of our talk, this episode, is the integration. That's what we want, right? We made LangGraph Agent. I showed you how it works. Now we want to implement it to Open WebUI via pipelines. There are two main things that you need to do. Messages transformations. You want to show chat histories or chat session in Open WebUI. Open WebUI has its own way of managing chat messages. Well, even though it's OpenAI compatible, you might need to make sure that you prepare the messages well, right? On the other hand, you have an AI agent. An AI agent needs access to a list of messages so it knows what was the conversation is all about, what we talked earlier. So LangChain has its internal message syntax like human message, AI message, tool message, system message, and so on. They are almost the same, but not quite. So you need to handle the message transformation properly. And we are going to take a look into that in code afterwards. Now, the second thing is the boilerplate, because you are making, you are using kind of like a pre-made tool from Open WebUI. You need to comply with their ways of work. And in this case, adopting the pipeline syntax or the boilerplate. And I'm going a little bit beyond here is I want my source code for my LangGraph agent to be somewhere else apart from the pipeline repo. Well, the reason is I want to make it once and deploy it everywhere. Everywhere can means my own Gradio interface, or for this episode, it's the deployment is going to be shown in Open WebUI. So the source code for my agent is not in the repo of Open WebUI pipelines. So this is just some management stuff that you need to do in terms of coding. So pretty much, to follow the boilerplate, we are cloning the pipeline repo from GitHub inside this folder. Under this folder again, you are going to make a file that will define and boilerplated your agent in order to be loaded properly. And as I mentioned, I'm using Poetry now, so I need to have make sure that all the all the modules and packages that I use in my LangGraph agent got added properly into the pipelines Poetry environment. And that's it. These are the core files in your pipeline repo. Well, demo time. So let's actually go into the detail now. All right, so let me talk about the highlight of the day here. You are adding a pipeline to the pipeline repos. Whatever you add must be in a correct format. It's going to be a Python module, meaning a file end up with .py. Put it there. Put it under the pipeline function. The headers should be formatted properly as well. And what I will recommend you here to study examples to understand what it is. Well, this is bad examples, no headers. But the Wikipedia has enough headers for you to study. This can mean this file, this module needs to be run with Open WebUI version 0.4.3, for example. Requirements means it will install it will require this packages to run this whole thing as it imports here. So yeah, those are the headings that you might want to study. But for me, as I told you, I use Poetry to manage dependencies, so I don't need to provide requirements over here. So I keep it minimum, title, others, or I can put my name there. Description, required Open WebUI version, and license over here. And you are going to import what you need to import here. But this is what I meant when I told you that my source code for the LangGraph agent is somewhere else. Therefore, I have to have a way for pipelines repo or the runtime have access to. This is going to provide the meaning of the source path by looking up to the environment variables. If it has that, if it fails, it will use this as default. This is probably not the most elegant way, but it gets my agent working or prototyping on my local machine. And this chunk of code is related to the source. Pretty much import things that I need Again, here, you can see here, the create agent builder is there. Get LLM. This is what I mean when I told you that you need to do message transformations properly. We'll get to this part later in the actual run code. Vowels. Vowels is something related to the pipeline boilerplate. Vowels allows you to change configurations of your pipeline in Open WebUI in Open WebUI interface. I will show you later, but I think it's going to be self-explanatory. Now, this is import functions and stuff from my source code properly. And here we go. The actual boilerplate is you must have a class pipeline. Inside the class pipeline, you must have a class vowels. And now I am, well, not the best naming, I think, but pretty much this vowels will inherit whatever vowels it is. And this vowels is the vowels that I defined there in the actual source code of my agent. So this is the vowel. So let me just actually, here we go. This is the actual vowels. Vowels divided in the actual source code. So there is only one configuration that I will allow people to change in Open WebUI interface is the model name. We'll see this when we actually run the pipeline. Now back to the pipeline repo. So the boilerplate must have the init. In this one, you set up the value of vowels properly. You set it a name, the agent a name, and I added a step to actually create a graph here. So when the pipeline is initiated, you have a graph ready. You have a compile here. Oops. Right? So once this pipeline is initiated, you have an agent ready to chat with you. On startup, on shutdown, not going to focus here. Now, another hero here is the pipe function. This is called every time a user submit a a user or you submit text. This function is going to be called. Pretty much, it's going to handle the LLM calls here. So what we do here, this is the Open WebUI version of the messages. We are now converting it to a LangChain version of the messages so that we can define a payload. Well, pretty much a LangChain messages. We will send it to a LangChain agent to work on. So yeah, pretty much converting Open WebUI version of messages to the LangChain version of messages, send it to the LLM. The LLM now return the LangChain version of a new messages, for which we would need to be then converted back to the Open WebUI version of the messages before we use this chunk of code to push it to the Open WebUI interface. That's how it is, guys. As I mentioned to you, there are two main things to integrate. The messages transformation, the code, you need to write some code to do that, and also the boilerplate. So the coding walkthrough cover everything that you can see here. But before we actually go to the actual demo, let me show you the conversion of these messages. The way I implement it here is back to my LangGraph repo again, because I want to keep it clean. So I keep it in UI tool. Here we go. Now the conversion convert messages from Open WebUI to LangChain is easy. LangChain core has that function for you. That function is called convert to messages, and it will handle roles properly, content and everything. So this is simple. On the reverse, from LangChain back to Open WebUI, you can use a utility function called messages to dates. It's going to convert LangChain messages to almost Open WebUI messages. You need to have the final touch where you unwrapped the key called data. Inside this data, there are many, it's a dictionary. It contains things like content, additional function calls. So in order to work with, in order to be 100% Open WebUI messages, you need to add the steps to convert it to the right format. But yeah, the conversion is not as difficult as it looks like. All right, now I told you everything about the codes. Oops. Oh, I did it again. Why did I do it? Oh my goodness. Okay, I need to. Oh God, sorry guys. I just keep hitting the wrong button. J. Okay, this is the LangGraph repo. It's not the pipeline repo, so we are not going to use it. We are going to focus on the pipeline repo here. Okay, so once your code is correct, you put it here and you run it, it will be fine. So to run it, actually, you know what? To emulating that it just started. Let's say you just put your code there. You will not have the folder that I just deleted. So when you run it, that folder will get created, meaning that the modules are correctly loaded and set up. Now the pipeline is ready and we can access it via the Open WebUI. And the name of this agent is the Data Analyst Agent. All right, so the way to do that here, let me check. Here we go. This is the pipeline. And the only vowels I give it is the model name. So it will show up here. The user has ability to choose the model they want. For this demo, I'll keep it GPT-4o. And the way to use your LangGraph agent is by selecting it from the model selection here. If you don't set it to default, you might have other models. To select the right model, you just need to put it there. And just for quick and easy thing, I will set it as default. All right, so if you recall, the agent is named Casey as I provided in the prompt. So I may ask, hi, Bench, what's your name? It should reply Casey, right? I am Casey, and that's great. So it's doing the right thing. Okay, now what we want to do, let's ask it to run what is error function. This is an error function used a lot in engineering of 0.1. So just recall that our agent has Python executor tool, and we also provided with a way to access Postgres database. We are going to show it everything here. All right, so seems like it knows how to write this code, and it wants to use SciPy. Now, you have to provide You have to provide the right environment to it too. And SciPy is have already been added to my Poetry TOML file and installed properly. Therefore, this run is successful because it can load, excuse me, it can load the SciPy code. Now, in the next demo, we are going to use our LangGraph agent equipped with a Python interpreter to integrate or interact with our Postgres database. So let me just run the pipeline so that we can see it in our Open WebUI. Here we go. Now the modules are, at least one of them, the Data Analyst, is uploaded or imported properly. Then we should be able to see it in our Open WebUI connection in the admin panel, settings, and pipelines. Now, here the default model is the O3 Mini. Should be good for reasoning tasks like this. So let me save that, and then we can start chatting with our data analyst. So first, let me ask it with what databases do I have in my Postgres server? We are going to hit run. And now we are waiting for the model to give us an answer. This time, we are quite lucky that the model can do it correctly. This is the thought that, okay, I need to connect to PostgreSQL and query the available databases to retrieve their names. I will execute an SQL query to get the names of all databases present in the Postgres SQL server. And now I will establish a connection and execute this query. And this is the Python code that the model thinks that it needs to do. And then it will use the Python executor to do that. And eventually it knows that, okay, we have two databases that we can connect to. And this is correct. And just to verify, this is my Postgres database running in my local machine right now. And we have two databases, the Postgres and Coffee Shop. So the model is correct. Now we can do this. What are tables available in coffee shop database? Then we are waiting for the model to generate an answer. Here, this is what it thinks, that it needs to write this code in order to connect to the server and query for the tables available in this coffee shop database. So let me just ask it to run the code. Okay, it seems like it can retrieve the correct tables in this database: store master, product master, and transaction data. So let me ask it, what columns are in transaction data tables? This step is necessary because right now the model doesn't really know what kind of columns are in this particular tables, and therefore when you ask it this way, if it can find the answer, it will then know what columns are in the table, and that will lead it to be better at query information from that table because now it knows what it needs to be done. All right, so I need to run the code. And yes, these are columns contained in my minimum version of the transaction data. Let me ask it with, what are columns in product master? Then run the code. Okay, these are columns contained in the product master table. Well, for completeness, let's ask for columns in the store master. Just to repeat why I'm doing this, this is because I want the model to get columns in these tables so that the information about the columns are then in the chat history. And then afterwards, when we ask the model to do some aggregation, then it knows it has context to start with, rather than it has to do everything on its own. Well, we are quite unlucky this time. The models, I think, made a lot of errors, and now it has reached a recursion limit, which is the default to 25. So we can ask it to try it again. Okay, this is the answer after we ask it to try it again, and it seems like it's still running into a lot of errors. So what I can do here is actually let it try it again by regenerate the answer. The second time, it still failed, so let me just regenerate it again. Okay, by regenerating it for the third time, the model can get to the right code and successfully get columns from the store master. So now let's add more difficult tasks to the model to do. This can be aggregate sales by product in February 2024, replace product ID with the product name, and rank from top to low sales. This kind of task requires the model to aggregate and join two tables together and then rank it. So this is quite a complex SQL, and let's see if the model can do that correctly or not, or how many tries that it needs to do. Okay, this is what it thinks that it needs to do. It needs to query from transaction data and join it with the product master in order to replace product ID with the product name, and then aggregate that and then rank. And this is the SQL query that it needs to do. And hopefully when we run it, it will be the correct answer. Somehow it's got an error. After I say run it, somehow it got an error and it's still not doing the thing that it thinks it needs to do. So I think I will try regenerate it again. Let me see. Now it seemed like it's run into a lot of errors and still couldn't find the right answer. So this time, let me just go back to the original question right here and try to regenerate this again. Well, this is still the answer. It's similar to what it did before. And so let's hope to get the answer by let the model run the code. Ooh, we are lucky this time. It looks like it's successful. So let's actually take a look. So run the code. It tried to run the code like this, run into some errors, and eventually, well, got the right code, I think. And well, run into error again and refix the code. And now this seems to be the right answer for it, right? Select product master, the product name, and the sums of total sales, and from transaction ID, join with the product master like that, and filter the time for February to be like this, and group by product name and so on. So this code seems to be okay, but I think it still make mistakes here because it's using total sales rather than the sales per item, because the way I configure this, the total sales is actually the sales of the whole bill, which can have more items in the same bill. So it's still making mistakes on that point. But at least if you remove that part or ignore that part, it's properly run the SQL and rank the product from top to least sales for you. So all in all, I think I have shown you the capabilities of the AI agent to discover databases and tables with the Postgres server that I have in my local machine, and also show you that you need to at least find a way to provide tables informations like columns to the model. And the way I did in this demo is actually ask it to retrieve columns from the from the tables, and when it was successful, you will provide by proxy of running this chat sessions, the AI will now know what kind of columns are in a specific table. And you also see that sometimes it made mistakes and you need to redo it, asking the model to redo it by clicking a regenerate button. And if you are lucky, it can solve the problem within a few trials. And if the question's actually more complex, then you might need to do a lot of trials, as I did and show you today. And also, more importantly, it's still necessary for you to check the code, whether it's the right one or not. But all in all, now our AI agent equipped with a Python interpreter can now write code in order to integrate with a Postgres database. That's all for the show today. So in summary, today we covered how to make AI agent, a multi-step agent with LangGraph, and you equip it with Python executor, and with that, it can do many things. The Python code can access database, and so that it effectively allows the AI to grab information from your data in response to a user queries. Today, we also see how to integrate your AI agent into the Open WebUI systems. This is done by means of custom pipelines. And there are two things that you need to handle: the message transformations, and we are going to keep or take the messages list in Open WebUI as a main thing, because we allow user to go back and change and edit and regenerate messages, and therefore the main part, the single source of truth is going to be list of messages in Open WebUI, and we just need to make sure that it transforms. We transform it correctly to the LangChain properly, and also set up the boilerplate. And you actually saw how unreliable a simple systems of multi-step agents is. The faults, the problems can lie in the prompt, the model that I choose to work with, and a lack of retry mechanisms or the guidance for the model to actually do complex tasks. This shows in rigorous testing, like what I did to you here. Luckily, it showed up. So making AI agent for prototypes can be simple, but making it reliable and awesome is more challenging than what many people would think. But it's a fun thing to do. So last but not least, don't forget to subscribe to a invitation, AI Agent Simplified. I am creating a courses, lots of courses, and also a community that will focus on practical and hands-on knowledge and insights and tools about implementing AI agents. So feel free to subscribe, and you'll be the first to know about updates and discounts or free information. Last but not least, please subscribe to our channel. Help me reach 10,000 subscriber by not 10, then not 10. All right. Help me reach 10,000 subscriber by the end of the year. All right. Thank you very much for today.